We have two ways to explain concentration. One way is that you see there is a capital M appearing on the bottle of reagent. Capital M is defined as molarity. So this is definition of molarity. If I say molarity of this solution is 1 mole per liter, it means you have 1 mole in 1 liter of solution. How much is 1 mole? You look up the table. If I say 1 mole of salt, you add mass of sodium chloride together. Mass of sodium and chlorine add together. 1 mole of sodium chloride is 58.5 grams. If you want to make 1 mole solution of sodium chloride, you weigh 58.5 grams. You add enough water, stir it until you have 1 liter, then you have a 1 mole per liter of sodium chloride. So one way of showing the concentration of solution is to determine number of moles of solute. In this case, it's table salt divided by volume of the solution. It could be 1 liter or 2 liters or 10 liters or 0.1 liter. Then you get molarity. That shows concentration. That means how much solute you have in a solution. Are you with me? So one way of expressing concentration is molarity. Molarity shows number of moles of solute in 1 liter of solution. Are you with me so far? Next. So concentration shows number of moles of solute in a given volume of solution. Is concentration in terms of molarity clear to you or not? If I'm talking about solid sodium chloride, I talk about number of moles. When I dissolve sodium chloride in certain volume of solution, then I talk about molarity. That means how many moles do you have in 1 liter of solution? So concentration of a solution is amount of the solute in a given volume of solvent. So if I say, what is molarity of a sodium chloride, which is obtained by dissolving 2 moles of sodium chloride, that means 2 times 58.5 grams. In 1 liter of solution, you say, I have got 2 moles, that goes on the top, on the bottom, 1 liter, so the solution is 2 mole per liter sodium chloride. How do you calculate molarity? Divide number of moles of the solute, sodium chloride, by total number of liter of solution which is made by dissolving sodium chloride in water. Are you with me? Any question? All right. So if I ask you, how much potassium iodide do you need to make 500 ml of 2.80 mole per liter of Ki? All you have to do is determine number of moles. Convert moles to grams. You already know how to go back and forth between grams and moles, right? So all I need to determine number of moles. So can I say, in this formula, do I have volume of the solution? Yes, it's in 500 ml, but I know how to convert milliliter to liter, so I have the bottom of this ratio. Do I have the top of this ratio? I don't. That's my unknown. If I determine moles of solute, I can convert it to number of grams of Ki. Do I have molarity here? Solutions says molarity is 2.80 mole per liter. So you really have one equation, one unknown. It's a very easy algebraic question. So can I say the way to solve this problem is to start with volume of Ki given by the problem, which is 500 ml. Use the molarity to calculate moles of Ki, and then convert number of moles to grams. Can I say that? Are you with me so far? Stop me if you are not. And don't be shy. So what is the volume? Is volume 500 ml?
Yeah.
Thank you. So can I convert that to liter? Going to the wrong direction, sorry about that. So how do I go to volume of Ki, to moles of Ki? I have to use molarity, which is 2.80 mole per liter. Once I have moles of Ki, how do I go to grams? Well, molar mass. You have done that a lot already. So I need liter of solution, and I have milliliter of solution. Do I need a conversion factor to cancel milliliter and go to liter? So can I write milliliter on the bottom and liter on the top? So now I have this bottom of ratio. I have number of liter of solution I'm trying to make. Next, can I use molarity to determine number of moles of Ki? What is molarity? Problem says 2.80 mole per liter. Capital M is mole per liter. So can I cancel liter and go to moles? Liter on the bottom, moles on the top. What is the relationship between top and bottom? 1 liter contains 2.80 moles of Ki. That's where this is coming from. And if I do that, I'll cancel liter and liter, cancel milliliter and milliliter. I am writing here moles of Ki. So next step, I want to cancel moles of Ki, go to grams of Ki. What do I do? Where should I write moles of Ki to cancel moles of Ki? On the bottom. I want to convert it to grams. 1 mole of Ki is 166 grams. How do I know? Look up the table, determine the molar mass of K, which is underneath K. Look at the number which is written in the table, periodic table, under I, add them together, you get 166 gram Ki. So can I say I have to check my conversion factors? Milliliter and milliliter are canceling, liter and liter are canceling, mole Ki and mole of Ki canceling. I'm left with one unit, that's gram of Ki. Problem was asking mass of Ki, which is grams of Ki. That means I have the right unit, so my conversion factors are correct. Go ahead, any question? Don't be shy, please. Any question? Great. So how, if I ask you make 1 liter of 1 molar table salt, how do you make it? Well, you take a 1 liter volumetric flask, because that's supposed to be the total volume. If I say half a liter, take a half a liter volumetric flask. These are very accurate. Then you calculate. Yes, go ahead.
Oh, sorry. Would you mind going back just to the last slide? I forgot just one piece of information from it.
Sure, no problem. Yeah.
Okay, good. Great. Thank you.
No, not at all. Guys, for your information, all of these slides, exactly what I use is on the Canvas. If you go to Canvas, go to Files, and then look at the presentation, you see all the slides there. So in case sometimes you miss something because I'm going too fast, that's another way of gaining the information that you need. Or you want to review, you can always do that. Thank you, dear. for asking.
Thank you.